Alright guys, so this video is properties of graphs, and we started talking about specific vocabulary words, and while we know what those vocabulary words mean, I want to specifically go over how we write it when we're talking and analyzing properties of graphs. So increasing means we're going up. But when we're talking about where a graph is increasing, we write it using the x values. And we read it from left to right. Okay, so this is video recap, but basically it's like the how to write, how to write it. Okay, decreasing, we know, means going down. And again, when we're writing it, we're only using the x values to describe it because we read graphs from left to right, not up and down. Okay, so let's just start there and let's do example number 1 together. So where's the graph increasing? So where is the graph going up? Right? And I'm going to highlight that. The graph is going up from here to here. Now, I can't use the y values to describe that because when I look at this y value or this range, right, it's not only just increasing during there. So when we're using that to describe it, we're starting at our x values. So when I look at my x values, I'm looking on this axis, right? And it starts increasing from -5 through, where does it stop increasing? If you look here, it stops increasing at -2. So whenever we're writing where the graph is increasing or where the graph is decreasing, we're going from left to right using our x values. Okay. So now where is the graph decreasing? The graph is decreasing on this other side. And again, when I do this, I'm using my x values. So I'm looking here to where it stops, which is here. So it's decreasing or going down from -2 through +1. Okay. You can also say when x equals -2 through x equals 1. Right, that's another way you can write it. Okay. So now let's look at our x-intercepts and our y-intercepts. First, let's look at it in our vocab. So x-intercepts is where it hits the x-axis. But when we are writing it, we are only looking at the x value. So let's look at this graph, x-intercepts, where it hits this x-axis. So I look along this line. There's 2 of them. It hits the x-axis here and here. Okay, so when I'm writing this, it hits the x-axis at the coordinate -4, 0, and the other coordinate is 0, 0. But I only care about the x value of those coordinates. So I only care about this. Because I'm only worried about where it hits the x-axis, the x coordinate. So my answer for number 3, where are the x-intercepts? X-intercept is -4, and x-intercept is 0. Okay, similarly, where does it hit the y-axis? I'm talking about this y-axis. And, oh, no. Just like we only focus on, this is the y-axis, we only write the y value. So where does it hit? Same point, but now I'm only focusing on my y. So the y-intercept is y equals 0. All right, so the next question is about the maximum. So I'm going to skip down here. Maximum is the largest coordinate or the largest y value. Okay, this specifically asks for a coordinate, but I also want us to write it as that y value. So when I look on here, I look for my highest point, that's here. That coordinate is -2, 4. And if you see, that's the biggest y value. So the maximum point is -2, 4. And the max y value is 4. Okay, symmetry. Is where it cuts it in half. All right, so where it cuts it in half, right down the middle. But we write it as x equals some number. So if I look here, this is my line of symmetry. And we write it as, is the graph symmetrical? Yes. And where is it symmetrical? Right here. And we write that as when x equals 2. So that represents this whole imaginary line. Okay? I know that is a lot. I know it's very specific on how to write it, so you're going to practice it more tomorrow in class. So go ahead and try example number 2. And then when you are done, please watch the rest of the video to make sure you got it right. Okay, so at this point, you checked it out. Lexi. Sorry, dog's barking again. Wants my attention. All right, increasing. Here it goes. Here's where it's increasing. Notice there's an arrow on the end of this one. So it starts increasing at 3. So from 3 through, this arrow means it goes on forever. That's called infinity. Okay? Where is it decreasing? So it starts increasing again. There was another arrow, so that's from negative infinity through, where does it stop? That same point, 3. All right, x-intercepts. Where it hits the x-axis, here and here. So that coordinate is 2, 0, and this one is 4, 0. Why am I zoomed out so much? Let me zoom in. There we go. Too much. All right, and I only care about the x value, so the x-intercepts are x equals 2 and x equals 4. All right, y-intercept, where it hits the y-axis. And I already see where that crossed. Right here. And that's when there's only one. The y-intercept is y equals, this coordinate is 0, 4, but we only care about the y. So y equals 4. Okay, before we define maximum, we didn't define minimum. This is the smallest value. And it's the same thing. It's coordinate or the smallest y value. Alright, so this one says what's the minimum point? That is a coordinate. So the minimum coordinate is 3, -2. And where is the graph symmetrical? I'll draw the imaginary line. It is symmetrical right down the middle. And again, we write that as it is symmetrical x equals 3. Alright, you're probably wondering, do we have to write it in this specific way? And the answer is yes. If we mess up our notation and how we're writing it, we might be describing a different thing. So it's really important to pay careful attention to that. We're going to go over this again tomorrow with an exemplar, and then we're going to continue working in our packet and try this out on our own. Okay, if you have any questions, feel free to write them here or answer them in the next question on the video. See you tomorrow.